welcome to the deep dive. Today, we're jumping straight into a common problem, really. Something many of you using AWS might hit.
Yeah, that dreaded EC2 instance status check failure.
Exactly, that little red flag. It can be a real headache, can't it? But what we want to do today is give you a clear, kind of step-by-step approach.
Help you figure out what's gone wrong and, get things running again fast.
Right. Think of it as a quick response guide for when those alerts pop up. Hopefully save you some time, maybe some stress too.
And we'll focus on the two main types you'll see, right? System checks and instance checks.
Yeah, precisely.
And just knowing which is which, that's like the critical first step in diagnosing it. EC2 failing a check is basically a clue.
A clue to where the problem actually is.
Yeah.
In the infrastructure.
Exactly. By the end of this chat, you should have a much better handle on how to tackle these things. More proactive, less just reacting.
Okay, sounds good. Let's start with the first type then. System check failures. What actually causes those?
So, system check failures, they happen when AWS itself detects a problem with the physical server, the actual hardware your EC2 instance is running on.
The physical server, like power issues, network card failures, that sort of thing.
Precisely. Power, network connection to the host, maybe some other hardware glitch on their end.
Ah, okay. So the key thing is it's external to my instance. It's an AWS infrastructure issue.
That's the crucial point. You can't SSH in and fix the physical box, right? It's their hardware.
Makes sense, especially with, multiple instances sharing the same physical host sometimes.
Yeah, these isolated things can happen.
So if it's an AWS problem down in the data center, what can we actually do? Feels a bit like our hands are tied.
Well, you can't go swap the hardware, obviously, but the fastest and usually the most effective first step, just stop the instance and then start it again.
Stop and start, not just a reboot.
No, specifically a stop, then a start, and here's why that works, or often works anyway. When you stop and then start it, AWS usually moves your instance. It provisions it on a completely different piece of physical hardware.
Onto a healthy host, hopefully.
Exactly. It cycles it onto what people often call fresh metal. And that simple move clears up most of those underlying host problems that caused the system check fail in the first place.
Right, okay. That makes sense. A simple reboot wouldn't move it, so if the hardware is faulty, rebooting won't help.
Correct.
So system check fail, try a stop-start first.
Got it. Okay, let's switch gears then. Instance check failures. This sounds more like something we can fix.
Exactly right. With an instance check failure, the underlying hypervisor, the software managing your VM, it can talk to your operating system.
Okay.
But the OS itself, it's not responding properly. So the problem is inside your instance.
Could be the OS, configuration, maybe applications running on it.
Yeah, any of those.
Yeah.
And this is where the real troubleshooting, the forensics, as you called it, really kicks in. Forensics, yeah. So, okay, instance check failure. Where do we start digging? What's the first thing to check?
Well, one of the very first things, especially if you can't even SSH in, which is common.
Right, yeah, can't connect.
Is to look at the console output or the serial console logs.
The instance console and the AWS management console.
Yep. These logs are gold because they capture the really early boot stuff, errors that happen before the network, before SSH even tries to start.
So you might see things like,
oh, kernel panics, critical OS crashes, maybe problems with etc. stab. That file tells the system how to mount its disks.
If that's wrong, it might not boot properly.
Exactly. Or even weird security things like Linux stopping the boot. It's like getting a window into that very initial startup attempt.
Okay, so that gives you the early boot picture, but it might not show everything.
Right. It has its limits. It might not catch issues that happen later or inside an application once it's running, but it's a fantastic starting point.
Okay, console output first. What if that doesn't show anything obvious? What's next?
Well, hopefully you've got the CloudWatch agent running on your instance.
Yes. Sending logs to CloudWatch.
If you do, then CloudWatch logs can be super valuable. They might show application errors, maybe disk space issues, things happening just before the failure. Gives you more context beyond just the boot.
Got it. Console for boot, CloudWatch for operational stuff. Okay. Now, .network, that seems like a common place for things to go wrong too.
Oh, absolutely. A bad network setup can definitely cause instance checks to fail, especially if health checks can't reach your application or your app can't reach something it needs.
So where do we look first on the network side? security groups.
Yep, security groups first. They're the instance level firewall. Check those inbound rules. Is port 80 or 443 open for your web server? Is your SSH port open?
And security groups are stateful, right? That's important.
Crucial distinction. Stateful means if you allow traffic in on a port, the return traffic for that same connection is automatically allowed out.
So you usually don't need explicit outbound rules for responses?
Correct. But people sometimes forget they might need other outbound rules for the instance to call out to other services, for example.
Right. Okay. Security groups checked. What's the next network layer?
Next up, network ACLs, NACLs. These are optional. They work at the subnet level.
And these are stateless, unlike security groups.
Exactly, stateless, which means you need explicit rules for both inbound and outbound traffic.
Ah, that's a common trip-up. You allow the request in, but forget to allow the response out.
Precisely. If you forget that outbound NACL rule, the response gets blocked, even if the security group allows it. Silence.
Okay, NACLs need both directions checked. Anything else network-wise?
Don't forget to route tables for your subnet.
Right, how the traffic actually gets routed.
Yeah. If it's a public instance, does it have a route to the internet gateway? Usually that 0.0.0.00 route pointing to the IGW.
And for private instances?
Check the route to your NAT gateway, or maybe a transit gateway if you're doing that. If the instance can't route traffic where it needs to go, health checks might fail even if firewall rules look okay.
Okay, so it's layers. Security group at the instance, NACL at the subnet, route table for the path. Makes sense. What if the network looks fine? What else could cause an instance check fail?
Well, always think, what changed recently?
The it worked yesterday problem.
Exactly. Check your package logs, like varlogeme.log on Amazon Linux or CentOS.
Or varlog dpkg.log on Ubuntu Debian.
Right. See if maybe a kernel update was recently installed. Sometimes those can cause issues.
Regressions or incompatibilities.
Yeah. Or did you deploy a new user data script recently? Change the instance's IAM role.
Good point.
Maybe try reverting that change or test it on a clone first, see if the problem goes away. Good change control helps here, obviously.
Definitely. Roll back the last change is often the easiest fix. Okay, so we've done some digging, checked logs, network, recent changes, but the instance is still failing. Are there any sort of gentler recovery steps before we get serious?
Yeah, a couple of things. First, the simplest. Just try rebooting the instance from the AWS console or CLI.
A simple OS reboot.
Yeah.
Stays in the same hardware.
Right. It's quick, sometimes clears up transient issues. If that doesn't work, then you go back to the stop and start.
The same one we talked about for system failures.
Yep. Because even for an instance failure, maybe there is some subtle underlying host issue impacting the OS, stopping and starting forces that move to new hardware.
Okay, but we need to remember the caveats there.
Right, absolutely critical. Remember, unless you have an elastic IP attached, the public IP address will change on a stop-start.
And instance store volumes.
Wiped clean. Instance store is temporary, tied to the physical host. So if you stop-start, that data is gone. Use EBS for anything important.
Right, EBS is persistent. Okay, so reboot first, then stop-start, keeping the IP and instance store in mind. Now, what if that doesn't work? You mentioned deep surgery, volume swapping.
Yeah, this is more involved, but it's super powerful if you think the problem is actually on the root dist itself, like file system corruption or a bad config file preventing boot.
So how does that work, roughly?
Okay, the basic idea is
Yeah.
You stop the broken instance, then you detach its root EBS volume.
Just detach the main hard drive.
Yeah. Then you need a working rescue instance. Has to be in the same availability zone.
Okay, a temporary healthy instance.
You attach the detached root volume to that rescue instance, but as a secondary disk, not the boot disk.
Ah, like plugging in a USB drive.
Kind of, yeah. Then, on the rescue instance, you mount that secondary volume. Now you can actually browse the file system of your broken instance.
Wow, okay.
And there's a command, croot, which is really useful here. It lets you temporarily change the root directory for your commands to the mounted volume.
So it's like you're operating inside the broken instance's file system, but from the safety of the rescue instance.
Exactly. So from there, you can edit files, like fix that broken etc. stab, maybe undo a bad kernel update, clear out log files if the disk is full.
Things you couldn't do if it wouldn't even boot.
Right. But be careful. Make sure you have backups before you start editing things this way.
Good disclaimer. So fix it up, then what?
Unmount the volume from the rescue instance, detach it, and then reattach it to your original instance, making sure to set it as the root volume again, usually DevXvita or DevZa1.
And then start the original instance.
Yep, and hope your fix worked. AWS also has a newer API in some places now for root volume replacement, which can streamline this a bit sometimes.
Okay, that's a pretty advanced technique, but I can see how powerful it is for fixing deep OS-level problems. What if even that doesn't work or seems too complex? What's the last resort?
Well, the final fallback is often just redeployment.
Start over.
Pretty much. Launch a completely new EC2 instance from a known good AMI, an Amazon machine image.
So you know you're starting clean.
Right. And this is where having your infrastructure defined as code, using tools like CloudFormation or Terraform, really pays off. You can just redeploy quickly and consistently.
Yeah, IAC makes this much less painful.
And also, using things like auto-scaling groups or launch templates, build resilience in from the start. If an instance fails a health check, auto-scaling can automatically terminate it and launch a fresh replacement from the template.
Self-healing, basically.
Exactly. That's the goal for robust applications.
Makes total sense. Sometimes a clean slate is the best way, especially if you can automate it. Okay, wow, we've covered a lot. From system versus instance failures through logs, network checks, rollbacks, recovery steps, all the way to volume swaps and redeployment. Can we try and boil this down? What are the absolute key takeaways for listeners?
Yeah, let's try. So status check failure hits. First question, does it feel like an AWS hardware thing? System check.
If yeah.
Try stop start first. Get it on new hardware.
Okay, if it feels like an OS problem inside the instance check.
Then start digging. Check the console output first. See if that gives you clues.
And if console isn't enough.
Then you might need to consider that volume swap technique to get inside and fix the root file system directly.
And don't forget the network checks throughout.
Definitely not. Always keep security groups, NACLs, and root tables in mind. There are very common culprits for instance check failures too.
Okay, that clarifies the main decision tree. You mentioned some memory hook to help remember this.
Yeah, just some simple ones. For system checks, host bad, stop start, new metal, gets you thinking about the hardware move.
Okay, host bad, stop start.
For instance, checks maybe, OS bad, console volume swap, fix, sort of the escalation path.
OS bad, console volume swap fix.
Got it.
And network.
For network, net bad.
Yeah.
SG-NACL, root AG, WNet. Think clockwise around the network layers.
SG and ACL route leading out via IGW or NAT. Nice. Those could actually be quite helpful in the heat of the moment.
Hope so.
And you also had some DevOps interview nuggets, real-world tips.
Oh, right. Yeah, just a couple of things you hear from experienced folks. One engineer really stressed checking that serial console first.
Oh, first.
They said, surprisingly often, it just flat out tells you the root cause right there. Like a corrupted festab file, kernel panic, saves a lot of guesswork. Their approach was often fix via rescue mode if possible, rather than just relying on stop-start, hoping the host was the issue.
Interesting. Get to the root cause faster. What was the other nugget?
Automation. Lots of teams set up CloudWatch alarms on that status check failed metric.
Okay, so when the check fails for, say, 5 minutes.
Yeah, something like that. The alarm triggers an SNS notification, which then kicks off a Lambda function.
And the Lambda function.
Automatically does the stop and start on the failing instance.
So it automates the most common fix for system-level failures.
Exactly. Creates a self-healing loop for those host issues. Can save a lot of page alerts in the middle of the night.
That's really smart. Incredibly practical tips there. Check serial console first and automate the stop-start for system checks. Great insights. So wrapping this all up, what's the core message we want people to take away from this deep dive?
I think the main thing is just feeling more confident when you see that status check failure. Understanding that split between system and instance issues is key.
Knowing where to even begin looking.
Right. And having that structured approach. Console logs, network checks, maybe the volume swap. It means you can work through it logically, reduce downtime, and get things stable again.
It's about pinpointing the real cause, right? Hardware, OS, or network.
Precisely. Find the cause, apply the right fix. That's the goal.
Absolutely. Knowing the path forward really turns that panic moment into just another technical problem to solve. So, for everyone listening, maybe take a second to think. How could you apply some of this proactively? Could you set up that automated recovery Lambda? When an alert hits next time, what's your first step going to be based on what we discussed?
Yeah, thinking it through now definitely helps when it happens for real.
Well, this has been incredibly informative. Thanks for taking this deep dive with us today.